our second part. So, determining if and how many intersections. So, after that first substitution has occurred, it's possible to determine if an intersection will even occur. And the way we do that is with the discriminant. So, what I've done is I've just copied what we've done already. So, we already know there's one intersection because we actually calculated. But say, for instance, I get it to this spot, okay, and this, I'll just go back for a second. This is after I've done my substitution, I've got everything to the one side. So after I have that, what I can do is I can actually calculate the discriminant. And when we actually calculate the discriminant, we can see that actually there would be one real root. Okay, so in other words, one intersection, so a tangent. So my D here, if I actually calculated it, so this is kind of an aside, would be B squared, which would be 20 squared minus 4 times A, and you can see A here is 1, and our C is 100. And when we do that, 20 squared would be 400. And when I calculate this, I end up with 400. And I would have a 0 for my discriminant value. And we know from previous lessons that if their discriminant equals 0, there is one real and equal root. Okay? Double root that is equal. Okay, so you can do that as well. It saves you a little bit of time, you know, 2, 3 lines rather than having to do a whole lot of factoring and quadratic formula to find that there is no solution. Okay, now another thing that we can do is a question similar to this. It says, if a line with a slope of 4 has one point of intersection with the quadratic function that's here, what is the y-intercept of the line? So a little bit different setup than our previous example. So what do I need to know? Well, the first thing, and I'm just going to get rid of this because I don't need it, is I have a line with a slope of 4, but I do not know the y-intercept. So I know that that piece of information gives me y equals from mx plus b. I have y equals 4x plus a certain b. So I do know that. So the same kind of thing that happened before, I'm going to use this equation to be my first equation, and I'm going to use my parabola is my second one. So I'm labeling them. That was the first step of solving a system. So that's our second one. And I'm going to sub 1 into 2. So I end up with 4x plus b equals, let's hold on a second, move this down. It seems to work better if I am down a little bit. 1/2 x squared. So I put my second equation in here. And just like the previous ones, I'm going to get everything to the one side. So I have 1/2 x squared, subtract 4x from both sides. So I end up with a negative 2x. I have a negative 8, and I would subtract b from both sides. All right, so what I'm going to do now is a couple different things. I don't like this fraction, and sometimes you were trying to multiply by things to get rid of fractions. This time I can, because on this side of the equation it equals 0, so I can multiply everything here by 2, and when I do that, that will get rid of the half fraction that's in front of my x squared. So minus 16 minus, and here I would have b times 2 as well. So 2b equals 0. Now the next step I need to do is I actually can look at the discriminant. Now the discriminant, because I want to intersect just at one location, a tangent line, I want to have my discriminant equal to 0. So I'm going to put 0 equals my b squared, so that's going to be negative 4 squared, minus my 4. Just hold on, I'm just going to move this down again. My a is 1, and my c is going to be the negative 16 minus the 2b. Move over, pen. Equals 0. Oops, sorry, doesn't equal 0. We already have the 0 there. So 0 equals, and doing the arithmetic, 16 negative 4 times the negative 16. We're going to end up with, let's hold on here, negative, positive 64. And we're also going to have negative 4 times the negative 2b, so we're going to have a positive 8b. So our 16 plus our 64, we end up with 80 plus 8b. Remember, we're solving for b, so that's 8b equals negative 80. And divide both sides by the 8, and so we would end up with b equals negative 10. Oops, negative 10. That was going to look like a 16. Didn't want that. Negative 10. So in order for a line with a slope of 4 to intersect this particular quadratic function at one location, b, the y-intercept, would have to equal negative 10.